wildest imagination could dream up, now attempted by a well-prepared man who is fully aware of his dangers. Robbie Madison is saying this is it. To the top of the arc, he wants to go.
Absolutely perfect landing for Robbie Madison. He nailed that one. The sweet spot we talked about. He made it look so easy.
What more is there to say? Now comes what has been said to be the hardest part. As if 10 stories skyrocketing into the air isn't enough. The free fall back down. Here it comes.
Robbie was leaning out there. He was looking down, and the weight of that motorcycle alone would terrify a normal human being. But Robbie's so confident as he goes to the edge of that 100-foot drop. He's checking the bike is in the right gear. You can see him there, pushing up and down on the shifter pedal. Here we go.
He did it! Higher than anybody has ever gone before, and successfully returns.
Velocity was undoubtedly the most important component in doing this stunt, as well as a great example of physics. In order to reach his goal to get to the top of the Arc de Triomphe, Madison was required to reach a certain velocity on his bike before going off the ramp. Reaching this, of course, required Robbie to increase the velocity as he rode on the track. To find the velocity, one would have to divide the change in distance by the change in time. In order to reach his goal velocity, Madison was required to accelerate on the bike. Acceleration is defined as the rate of change in velocity. Obviously, Madison's velocity had to have changed when he started to ride. If he had been going at a constant velocity, he would not have cleared the jump. A projectile is an object that has no other forces acting on it other than the force of gravity. At the point when Madison clears the ramp, he and the bike become a projectile. Both him and the bike travel 60 plus feet in the air with only gravity acting on them. Also, notice the shape of the trajectory. It is a parabola, which is the common shape of trajectory for projectiles. Friction also played a part in this jump. As Madison rides along the track, there is kinetic friction between the wheels of the bike and the track. The wheels of the bike move one way while the friction moves the other way. The friction is what makes reaching such high speeds difficult. Work is done when there is a transfer of energy in which a force is applied to move something. In order to start his bike, Madison had to apply a force to the pedal. The force applied to the pedal made the bike move, therefore achieving work. Madison and the bike both have kinetic energy, which is the energy of motion. Any object with motion, whether it be vertical or horizontal, has kinetic energy. Since both Madison and the bike are in motion, they have kinetic energy. Potential energy is known as stored energy, which mostly comes from the location or position. A projectile has potential energy when it reaches the peak of its trajectory. Therefore, Madison and the bike have potential energy as they reach the highest point before landing on the arc. Newton's first law of motion states that an object at rest will stay at rest, and an object in motion will stay in motion at a constant velocity unless the forces are unbalanced. This comes into effect with Madison's startup and stopping of the bike. The bike is at rest until Madison applies a force to the pedal, causing the force on the bike to unbalance, which makes it move. The same goes for slamming on the brake. The bike is in motion until Madison applies a force on the brakes, which stops the bike. Newton's second law states that the acceleration of a system is proportional to the net or unbalanced force of the system divided by the mass of the system. In simpler terms, it is saying that if you push an object, it will accelerate in the direction you push it. If you push it with more force, it accelerates more. If the object has twice as much mass, it accelerates half as much. This applies to Madison in many ways. He pushed forward on the bike, making him accelerate forward. He pushed a great deal harder on the gas, which made the bike accelerate faster. And finally, since he had both the mass of him and the bike, the mass doubled, making the acceleration decreased, causing him to have to make it greater. Newton's third law states that every action has an equal and opposite reaction, or, in simpler terms, forces are the result of interaction between objects. When Madison pushes off on the ground pushes back on the bike, causing the wheels to move. Also, the force being exerted on the bike and the ground is the same. However, the ground doesn't move because the earth is more massive than the bike is.